Hi. So let's start our next question for today. That is kth element of two sorted arrays. Let's see what the question says. You are given with two arrays, array 1 and array 2 of different size n and m, and you have another element k. Your task is to find what would be at the kth position of the final sorted array. So you are given two arrays. You have to sort them, like you have to merge them together, and in the final sorted array, what will be the kth element that you have to find it out. Let's say here you have two array, and after final sorting, the array will look like this: 1, 2, 3, 4, and 6, 8, like that. So you have to find fifth element. So how you can find that? 1, 2, 3, 4, 5. You can see fifth element is 6. So 6 will be the output. You have to return that element. Okay. Now let's go to the approach. Let's continue, copy this input. Okay. So what we can do, we can first go for the merging approach. We know how to merge two sorted array. If this has length of m, this has length of m, we can merge two sorted array in order of n plus m. Okay, you don't require to merge and then sort. You can merge it along with maintaining the order. How? Like you can maintain two pointer I and j. Now which has less number, that is j has less 1, so 1 will be added to the final sorted array. After that 2 is less, so 2 will be added. 2 and 4, now j will be incremented. 2 and 4, between 2 and 4, 2 is sorted smaller, so 2 will be added first, then I will be incremented. Like that you can do this merge to sorted array. It will require order of n plus m time, and after that you can find kth element in constant time. Okay, so this is one of the approach which is okay. So can we do anything better? Yes. So let's look at another approach. Array 1 equals to 2, 3, 6, 7, 9. Array 2 will be 1, 4, 8, 10. Now look at this. If we want to find kth element, there are total 9 elements in that array, isn't it? There are total 9 elements in the array. That means you have to divide the final sorted array into two parts, where here will be 5 elements, and here you will get 4 elements, and the rightmost element of fifth element will be your answer. Okay, now you have to look, can we do that? We looking at this array, these two array, without merging these two, can we divide our array into two parts, like one will have 5 element and another will have 4 element? Let's see. Let's do a linear search. Now here I get 2. Okay, let's consider I am taking these two as in my answer. Okay, then from array 1 we are taking just till 2. Okay, so we have got already one element. How many elements we want more? 4 elements, because here we need 5 elements, so we want more 4 elements, so we have to take the array 2 total. So when, let's say here it is denoted by I and it is denoted by j, when I will be like 0, At that time, what will be the j? When we will take 2, then let's say our I will be at 1. We are considering the next position. So when I will be at 1, at that time j should be 0, 1, 2, 3, 4. At 4. Okay. So if I plus j sum equals to 5, in that case, that is we have divided one element from array 1 and 4 element from array 2. But we cannot just divide it. We have to also check is that division is valid or not, isn't it? Now, how you can understand that? Look at this. When consider a sorted part like 1, 2, 3, 4. If you divide like that, what will happen? Like if you take these two division, 4 will be less than 6 and 3 will be less than 8. If these conditions are satisfied, that means your division is perfect. Now here if you consider this, 2 is here and here there is no element, let's say. So that means it is by default true. Now here it is 3 and here it is 10. So 10 should be less than 3, isn't it? 10 should be less than 3, but that is not the case. This element should be more when there will be a valid division. Let's say we divide it by here. So if this is L1, this is R1, and if it is L2 and if it is R2, then L1 should be less than equals to R2 and L2 should be less than equals to R1. In that case only this partition will be a valid partition, isn't it? So can you do partition like this? Look at this. Here now you have this is L1, this is L2, okay, this is R1, this is R2. Now if we see that now 8 is greater than 7, which is wrong, which should not be. Like L2 should be less than equals to R1. So this is not satisfied. Here it is satisfied, no problem, but this is not satisfied. So you cannot partition the array like this. Now can you see that 1, 2, 3, 4, 6? After that you have to take 7. You cannot take 8. That's why this is not valid partition. So that is the thing I was talking about. So we have got our condition when a partition is valid. So what we can do, we can go for a linear search. 7, 8, 9, 1, 4, 8 and 10. So we can first take I equals to 0. So when I equals to 0, what should be our j? J should be, we want total 5 elements, so j should be 5. Okay. Now if we see here, j equals to 5 is not a valid index, not a valid number of elements. There are only 4 elements in array 2. This is array 1, this is array 2, this is denoted by I, this is denoted by j. Okay. So this is not a valid index. Now what you will do to make it valid? You will increase I. If we increase I, what is j actually? J equals to k minus I. So if we increase I, j will automatically decrease. Okay. So increase I equals to 1. In that case, j equals to will be 4. Now this is a valid index. Yes, index is valid, but let's say partition is valid or not. In this case, L1 will be 2, L2 will be 10, R1 will be what? Now we are doing partition from here and we are here. R1 is 3 and R2 is something should be greater than 2. Let's say we have int max here. Max. Okay. So it will make it by default true. So this is some max number. If we compare L2, is L1 is less than R2? Yes, we have no problem. But consider this case. L2 is not less than R1. So this is not a valid partition. This is not a valid partition. Now consider for I equals to 2. J will be what? 3. Okay, because in total we need 5 elements. What will be? L1 will be 3. L2 will be 3. So take 0, 1, 2, 3, like this. L2 will be 8, R1 will be 6, and R2 will be 10. Okay. If we see again, L2 is not less than R2, R1. L2 is not less than R1. So this is not also not valid partition. Consider I equals to 3. In that case, J should be 2. L1 should be L1 should be 6. L2 should R1 should be 7, and L2 should be what, 2. So we have J equals to 2. So that is 4, and R2 should be 8. Okay. Now that is all. Now look at this. Is this a valid partition? L2 is less than R1. Yes. L1 is less than R2. Yes. So this is a valid partition. So what is the valid partition? Valid partition will be this. Take 3 elements from A1 and take 2 elements from these two. Now if we do sort this, okay, we will get the kth element, fifth element at the last. Now we don't need to actually sort it because we already have pointed to this. If we take maximum out of this, that will be the fifth element, because 1, 2, 3, 4 and 6, the maximum will come, maximum of these last two element will come last, and that will be the your kth element. So that's how you can find it out. Now in this process also you are doing order of n time. You are spending order of n time because you are traversing the A1 array. Now that same work can be done in order of log n time. Can we do it in order of log n time? Yes, obviously, because these are a sorted array and we are doing a linear search. Then why we will do a linear search? Let us do a binary search. Okay. Now let's again do this. 2, 3, 6, 7, 9. 2, 3, 6, 7, 9. 1, 4, 8, 10. 1, 4, 8, 10. Okay, array 1, array 2. Now, what will be for binary search? We will have a left. So we are doing binary search on A 1, so 0, and R should be, so 0 means here, and what should be R? 1, 2, 3, 4, 5. R can be till 5. When R equals to 5, that means we are taking all elements of A1. Okay. Now this is all. Now we can calculate our mid. That will be 2. So we will keep divided by here. So if m equals to 2, that means how much we will divide from A1 array, because LR are representing the ends of A1 array. So what will be mid 2 then? Mid 2 will be 3. Now mid 1 obviously will be in the range L to R, but mid 2 can also be out of range, because when mid 1 will be 0, at that time mid 2 will be 5, which is out of range. So that we have to take care of. Now M2 equals to 3, that means we have to take 3 elements from M2. Okay. Now we have to check, we have to first assign L1, L2, R1, R2. L1 is 3, L2 is 8, R1 is 6, R2 is 10. Now is this a valid partition? Because L2 is less than R2? No, this is not a valid partition. Now look at this. Look at this. This is a most important uh, thing. Like L2 is more than R1, isn't it? What is the problem? this is bigger than this. So what you will do? You want to go more right side so that instead of 6 you get some bigger number, and instead of 8 you will get some low number. Like when you will go this side, automatically j will go this side because j equals to k minus I. So you want to go this side so that you can maintain this. Like if you go 6 to 7, what will happen? 7 will become bigger and this will go one side left, so 4 will become less. So what will happen if L2 is greater than R1? In that case, you will increase the low. You will increase the low so that you can go more right side. Because if you come right left side, it will the number like the number R02 will be more lesser and L2 will be more bigger. But we don't want this because R1 is already small. So we don't need to make it more small. We want to make R1 bigger and L2 small. So to do that, we have to go to the right side so that R1 will be more. So now when we will go right side, this is L1 will also go up and R1 is also going down. But okay, there are distance still there is a distance. So we can do that. Now if and another case when L1 is greater than R2? Yes, you have guessed right. That is, high should be updated to mid 1 minus 1. Okay. So let's implement this. So obviously we have a low and high. So low will be 0 and high will be n. Okay. Now while low is less than equals to high, we will calculate mid 1. Mid 1 equals to low plus high by 2 and mid 2, which is equals to k minus mid 1. Okay, now we got number of elements. Okay, now we have to take care of mid 2 that I have said, because we have how we are getting mid 2, that is subtracting m1 from k. So m1 will be in its proper position but m2 may not be. So if m2 is less than 0, that is a invalid position. In that case we have to do anything. And if m2 is greater than m, in that case this is an invalid position. We have to take care of this also. Now we will see how we can take care. Let's see. Like for this case, let's say 2 3 6 7 9. Okay, let's say we did partition from here. M1 equals to 0. At that time M2 will be 5, k minus M1. Okay, so it will be 5, which is an invalid range. Like m equals to here, it is 4 because there are 4 elements, but m2 is 5, so you cannot do this. So what at that time you have to do? You have to increase m1 so that m2 should decrease. If we increase m1, m2 will automatically decrease and it will come in that range. So if m2 is greater than m, if m2 is greater than m, in that case what you have to do? You have to increase the range. So L equals to mid 1 plus 1. Sorry, you have to increase the forward the mid 1 so that it comes in the range, and you can continue your program. You don't have to go anywhere else. And right will be, for if m2 is less than 0, at that time we will want to take lesser element from a1 array so that m2 increases. So to take lesser element, m1 minus 1, r should be updated to m1 minus. So we can continue from here also. Now we need L1, just a minute. Okay, so we need L1, R1, L2, R2. Okay, now let's define what can be this. Now L1, that is left one. That means when, look at this, when you have L equals to 0, at that time, this is okay, not problem. Actually L1, let's look at L1. Now when index is here, no problem, mid. Now when mid will be at 0, at that time you want to make any comparison from L1 to the R1, always true. So that, so what you can do, we can make L1 a very low number. So if M1 is equals to 0, in that case L1 you can assign int mean. Otherwise you can assign array of 1 M1 minus 1, that is L1. Okay, now if you are clear with this, you can do the same with L2. That is, if M2 equals to 0, in that case int mean, otherwise M2 minus 1. Now consider for R1. R1, so when M1 will be at the end, so at the end, at that time you can assign int max to R1. Otherwise you can simply do array1 of mid 1. And again for R2 also, M2 equals to M. In that case int max, otherwise array 2, sorry, this will be array 2 of M2. Okay, now I think this is clear. So for L1 we are selecting from array 1, M1 minus 1 element, you can look at that index, and for R1 it will be M1, M2 minus 1 and M2. Okay, now let's come to our condition. If L1 is less than equals to R2, if L1 is less than equals to R2 and also L2 is less than equals to R1, in that case we have no problem, and this is a valid partition. So this is a valid partition. If this is a valid partition, we can return max of L1 and L2, two left elements. Okay, else if, now if L1 is greater than R2, if L1 is greater than R2, let's see what was our condition. What, where did I write this? Yeah, so if L1 is, if L1 is greater than R2, in that case we have to update H as mid minus 1. So high should be updated to M1 minus 1. And at the else case, we can update our low to mid 1 plus 1. So that's all. At that last, if we don't get anything, in that case we can return minus 1, because if k can be out of range also, that we also can check here, like if k is greater than m plus n, in that case I can return minus 1. Okay, because this is given, k will be in that range. Okay, so that's all. Let's compile and run our program. Do we have any problems? Compilation error for R, because this should be H. Okay, is everything okay? Yeah, I think no. There is some problem. L2 is less than equals to R2, then we can return this. Okay. So for L2 and R2, we are comparing M2. M2 if greater than M, in that case we will update our low to more. Okay, to get less number from array 2, and this is okay. No problem. Okay. So if L1 is more and R2 is small, in that case we want to reduce. Yeah. So high will be updated to M1 minus 1. High will be updated to, yes, M1 minus 1, and low will be updated to M1 plus 1. Oh, okay, okay. I have written minus 1 within the while loop. I'm sorry. So now you can compile and run. I think this should work. So yes, this is working. Let's submit our code. So okay, this is correct. Now this is a very interesting question, and this is a really very good question. This question has came in Flipkart and Microsoft. So that's all. Thank you.